In the boundless expanse of the cosmos, where the very fabric of reality shimmers and twists, a question as ancient as the stars themselves echoes through the void. How did life begin on Earth? In this first part of a two-part series, we embark on a journey revealing a cosmic saga of life's origins. Imagine a universe where the seeds of existence are scattered by ancient hands, where every organism is a thread in a grand tapestry woven by unseen weavers. Join us as we unravel the enigmatic theory of directed panspermia. First proposed in the 5th century BC by the Greek philosopher Anaxagoras, panspermia suggests that life exists throughout the universe, distributed by meteoroids, asteroids, comets, and even interstellar dust. Directed panspermia, however, is an idea born in the twilight zone between empirical science and visionary speculation. This hypothesis posits that life on Earth was the result of a deliberate act of seeding by an advanced extraterrestrial civilization. Picture a race of beings casting the seeds of life across the galaxy, like greenskeepers nurturing a celestial garden. Unlike natural panspermia, where life drifts aimlessly through the cosmos on asteroids and comets, directed panspermia suggests intent, purpose, and design. The architects of this theory dared to ponder the improbability of life's spontaneous genesis. To them, the intricate machinery of life seemed too precise, too complex to be a mere accident of nature. Consider the DNA molecule, a structure so elegant in design and profound in its implications. Could it be that our very genetic code was written by extraterrestrial hands? Was it dispatched across the void in resilient capsules, engineered to withstand the harshest conditions of space, until they found fertile ground on a young Earth? In this vision, the cosmos itself becomes a vast laboratory, with life as the ultimate experiment. Each organism, each cell, a testament to the ingenuity of its creators. And we, the sentient offspring of this grand design, are left to decipher the messages encoded in our very being. As we delve deeper into the concept of directed panspermia, we step closer to understanding our place in this cosmic narrative, where every question answered births a dozen more, and the line between creator and creation morphs into a dance of infinite possibilities. To delve into the scientific foundations of directed panspermia is to step into a world where the lines between the empirical and the speculative intertwine. At the heart of this theory lie the musings of some of the most brilliant minds of our time, scientists who dared to look beyond the conventional wisdom of their age. The first modern reference to the concept of directed panspermia appeared in the 1930 science fiction novel Last and First Men by Olaf Stapledon. In it, he wrote, "In respect of the future, we are now setting about the forlorn task of disseminating among the stars the seeds of a new humanity. These objects we shall project from beyond our atmosphere in immense quantities at certain points of our planet's orbit, so that solar radiation may carry them toward the most promising regions of the galaxy." 40 years later, in a 1973 article in the planetary science journal Icarus, Francis Crick, co-discoverer of the DNA double helix, alongside the biochemist Leslie Orgel, pondered a radical idea. What if the complexity of life could not be attributed solely to the slow grind of natural selection? What if an intelligent force had a hand in shaping the building blocks of existence? Their hypothesis hinges on the intricate structure of DNA, a molecule so complex, so finely tuned, that it seems almost inconceivable it could have arisen by chance. They proposed that life's origin could have been engineered and sent to Earth from a distant civilization, one that had already mastered the secrets of biology and the cosmos. The scientific community, ever skeptical, demands evidence, and though hard proof remains elusive, tantalizing clues persist. Amino acids found on meteorites, as well as the discovery of extremophiles, organisms thriving in conditions previously thought uninhabitable, all point to the resilience and universality of life. These findings suggest that life's building blocks are not confined to Earth, but are scattered throughout the universe, awaiting the right conditions to flourish. Directed panspermia, therefore, challenges us to rethink our origins, to consider the possibility that we are part of a grander design, a cosmic experiment. Imagine a civilization so advanced that it has unlocked the secrets of life itself, capable of engineering organisms to survive the harshest environments and propelling them across the vastness of space. This is the essence of directed panspermia, the deliberate seeding of life throughout the cosmos. But how could such a monumental task be achieved? In the laboratory of an alien species, microorganisms are meticulously crafted, tailored to endure the perils of interstellar travel. Encased in protective shells, these microbial astronauts are designed to lie dormant, withstanding the vacuum of space, cosmic radiation, and the passage of millennia. These life-bearing capsules are then launched on a journey through the void, perhaps aboard automated spacecraft, or propelled by the sheer force of stellar winds. Consider the challenges of such a mission: the vast distances between stars, the hazards of interstellar space, and the need to accurately target hospitable worlds. Each obstacle requires ingenuity and precision. The alien architects of directed panspermia must possess technologies far beyond our current capabilities, harnessing the power of advanced propulsion systems, sophisticated navigation, and perhaps even the manipulation of space-time itself. Upon reaching a suitable planetary system, these capsules enter a new phase. As they approach a young, dynamic world teeming with potential, they deploy their precious cargo. Microscopic life forms, dormant no longer, awaken and begin the arduous task of colonization. They adapt to their new environment, exploiting every niche and eventually sparking the evolutionary processes that lead to the diversity of life we see today. In this vision, Earth becomes a fertile garden, cultivated by unseen hands. The initial seeding sets in motion a cascade of biological innovation, each new species, each adaptation, a testament to the ingenuity of its cosmic progenitors. In our quest for truth, we must grapple with both clues and conjecture, piecing together the cosmic puzzle with fragments of reality and shards of imagination. Directed panspermia, a theory so grand in scope, demands scrutiny and impartiality in equal measure. As we sift through the sands of time, however, we find tantalizing clues that hint at a deliberate seeding of life. Consider the meteorites that have fallen to Earth, bearing within them amino acids and organic compounds, the very building blocks of life. The Murchison meteorite, for example, contains over 70 different amino acids, many of which are not found on Earth. Could these cosmic travelers be the remnants of an ancient seeding mission, scattered across the stars to ignite the spark of life wherever they land? Then there are the aforementioned extremophiles, organisms that thrive in environments once thought inhospitable to life. From the scalding hydrothermal vents of the ocean floor to the frozen deserts of Antarctica, these resilient beings challenge our understanding of life's limits. Their existence suggests a form of life adapted to survive the rigors of space travel and planetary colonization, echoing the principles of directed panspermia. In the realm of genetics, we encounter further mysteries: the so-called junk DNA, vast stretches of our genome whose purpose remains elusive. Could these sequences be the remnants of an ancient alien code, a genetic legacy left by our cosmic forebears? Researchers like theoretical physicist Paul Davies speculate that our very DNA might contain messages from these ancient architects, encoded instructions awaiting our deciphering. And while many take issue with the concept, researchers like Sir Fred Hoyle and Chandra Wickramasinghe argue that life on Earth may be the result of an extraterrestrial origin, a type of cosmic creationism occurring throughout the universe. Yet, for every piece of evidence, there are gaps and uncertainties. The critics of directed panspermia argue for terrestrial explanations, pointing to the robustness of natural selection and the adaptive power of life. The absence of direct proof leaves room for skepticism, but it also leaves room for wonder. As we navigate between evidence and speculation, we are reminded that the quest for knowledge is an ever-evolving journey, one that challenges us to look beyond the obvious and embrace the unknown. To fully grasp the implications of directed panspermia, we must venture into the realm of advanced alien civilizations, beings so far ahead of us that their technology and wisdom border on the miraculous. These hypothetical architects of life are not mere figments of science fiction, but plausible entities within the vast expanse of the universe. Imagine a civilization that has transcended the bounds of its home planet, mastering the secrets of biology, chemistry, and space travel. Such a civilization would possess the capability to engineer life at a molecular level, designing organisms to endure the harshness of interstellar journeys. These beings might view the seeding of life as a form of cosmic philanthropy, a way to ensure the proliferation of life throughout the galaxy. Or perhaps it is a means of preserving their legacy, spreading their genetic material to safeguard against extinction. The motivations of these ancient architects may be as varied as the stars themselves. They could be driven by curiosity and the desire to understand and witness the evolution of life in diverse environments. Or perhaps they see themselves as cosmic gardeners, nurturing the seeds of life across the universe. In their eyes, life is a precious gift, meant to flourish and adapt, to create and evolve. In the annals of human history, we find echoes of these advanced beings. Mythologies and legends speak of gods and visitors from the stars, beings who imparted knowledge and altered the course of civilizations. Could these stories be distant memories of encounters with our cosmic progenitors? Imagine the shifts in perception if this were found to be true. No longer are we the result of random chance, but of a grand design. Our DNA, a complex code that guides our development and evolution, becomes a message in a bottle, cast adrift in the cosmic ocean by an advanced civilization, or perhaps many civilizations. If this all sounds far too fantastic, consider this. Since the launch of Sputnik by the Soviet Union in 1957, human beings have sent more than 16,600 satellites into space. These include more than 88 planetary probes, along with Voyager 1 and 2, which have both left the heliosphere, the bubble of solar wind that surrounds our solar system, and are now in interstellar space. If humans were capable of putting thousands of satellites into space in less than 75 years since the launch of Sputnik, imagine how many probes a civilization 1,000, 100,000, even 1 million years ahead of us could launch since their initial steps into the ether. The number would be almost impossible to estimate. But even if only a small percentage of alien probes were purposefully designed to carry microbial life, the number would be in the millions, perhaps even hundreds of millions. And given that the number of civilizations in the Milky Way may number in the tens of thousands, there is the very real possibility that our galaxy alone is replete with such microbial carrying vessels. In other words, the possibility that we are the product of such a grand design increases exponentially. In the realm of directed panspermia, we stand at the intersection of science and speculation. However, we must remind ourselves that science is a journey of perpetual curiosity, where even the most controversial theories invite us to look beyond the horizon and ponder the infinite possibilities of existence. And that includes life on Earth having an extraterrestrial origin. Thank you for watching. If you found this video insightful, don't forget to like and subscribe for more thought-provoking content. Only on Cretonium.